Now let's find the area enclosed between the two curves. F of x is x squared and g of x 1 over 1 plus x squared. So the first thing that we're gonna do is we can find or do a simple graphing of the two functions to have an idea where these two functions intersect. And we know how to graph the x squared. Let's see, between minus 1 and 1. X squared is something like this. Okay, so this is my first function. For the second one here, I can see that when x is 0, it's 1. Okay, it's even. This function is even as x squared, and it's going to be decreasing as the values keep increasing. Okay, here, see that I'm going to get something like this. Okay, and the most important thing is this point here. So this is 1, but this point is my point of integration because I'm trying to find the area between the two curves. So the area between the two curves is this area here in red. So this is the area enclosed between the two curves. This is 1 over 1 plus x squared, and this is x squared. And this is the area between the two. And now here, this is 0, and I need to find this value. But this one here, I'm only using when x is positive. The other area is symmetric with respect to the y-axis. So I'm not going to compute that. If I can compute this one, I can multiply it by 2 and get the area. So basically, I'm interested, let's call this value here beta. So I'm interested in computing this one, 0 beta, between which function is on top. So it's 1 over 1 plus x squared. So 1 plus x squared minus x squared dx between 0 and beta. But I need to multiply that by 2 because when I draw the other part, it's going to be symmetric. Okay? And the reason for this is that if we have a function that's even, and I'm computing the integral between minus a and a, so this integral is just 2, 0, the integral between 0 and a of f of x dx. That's what I used here. So if we can think of this function 1 over 1 plus x squared minus x squared as f of x, this is even function, and therefore this is what we did here. Okay? Now to find this point where they intersect, we have to solve this equation. We have to solve x squared equals 1 over 1 plus x squared. Okay? These two are positive. So we cross multiply, we're going to get x4 minus x4 plus x squared minus 1 is 0. Okay, now I can let u equals x squared, and u has to be positive. So here I have u squared plus u minus 1 equals 0. I can use the discriminant, and I get 5. And therefore, u is going to be minus 1 plus minus square root of 5 over 2. Only when u is positive, because I have u is minus 1 minus square root of 5, minus square root of 5 over 2. This is negative, so it's not accepted. And the other one is minus 1 plus square root of 5 over 2, which is positive. And therefore, x squared, which is equal to u, is going to be square root of 5 minus 1 over 2, and therefore x is going to be plus minus square root of 5 minus 1 over 2. So my beta point of intersection is going to be the positive one. It's going to be the square root of 5 minus 1 over 2. The negative one is going to be here. Okay, but I'm not interested in that, so I can integrate between 0 and beta and multiply the integral between 0 and 2. 0 and beta. And multiply the integral by 2. So I need to compute the integral between 0 and beta of these, the difference of these two functions, and after that I multiply it by 2. This is said, mathematically speaking, I need to do the following. The integral, which is the area between the two curves, is going to be 2, the integral 0 beta, where beta is this value, of which function is on top. So it's here. 1 over 1 plus x squared minus x squared dx. So this is the setup. I can stop here, okay? But I can do more because I now this one here I can integrate. So it's gonna be arctangent of x minus x cubed over 3 between 0 and beta. So therefore my integral is gonna be 2 arctangent of beta minus beta cubed over 3, where beta is this value. Okay, the square root of the square root of 5 minus 1 over 2. So basically this is my integral. So this is the area enclosed by these two curves. Okay, and we are here trying to set up to see and to just learn that if we have two graphs or two curves or two functions, the area enclosed between the two is given by AB f of x minus g of x, absolute value, okay, dx. A and B are the lower limit and the upper limit of the integrations. Here, since this function is on top, we don't need the absolute value. Okay, because this is positive, because f of x in this case is 1 over 1 plus x squared, and g of x is just x squared, and this one is positive. Sometimes we have g is on top of f, and we need to have a minus. That's why we need to have this absolute value thing. Okay, and we're gonna see more application for this one where we have to use the absolute value. For now, we see why we didn't use it. Okay? Thank you very much.